Today, I want to show you how CrateDB can be used to store embeddings and run similarity searches against those embeddings by setting up a RAG pipeline using LangChain. The RAG pipeline enables you to use your enterprise data and to use a large language model, aka an LLM, to answer in a nice human-readable format. So LangChain is a tool that has native integration with CrateDB, and it supports over 70 different LLMs. We are using today publicly available Twitter/X data for Microsoft support and show you how to use the data and build the chatbot around it. So there was enough talking for now. Let's go into the Juniper notebook and walk you through how we actually do things. So let me share my screen. So CrateDB is open source. So everything is on a GitHub, so you can find everything from source code. But we also have some nice examples. For example, this example is a CrateDB RAG customer support using LangChain, the Juniper notebook. So what I will do today is walk you through this and show you how quite easy it is to actually do this. So what I will do here to speed up time, and also because it's not that interesting to run the pip install, because basically we're using Colab here. So this is like a virtual environment within Google. So I will skip that part, but you can see that I actually ran that. So what we need to do then is basically set some basic stuff in regards to the different packages to make sure that we have the LangChain OpenAI packages activated within Python. We also have pandas to actually use the data frames and that kind of stuff. And here we have the configure database settings. So this is an important thing. In this particular case, you can see that I'm using basically my own sandbox, right? So and that runs on EKS, in EUS, on AWS. So this is basically what we do. But of course, you can also use like your local CrateDB, right? Because that's also one of the things I didn't mention, but CrateDB runs everywhere, right? So you can run that in a containerized environment, aka you can run that in Docker, you can run the Kubernetes, virtualized environments, of course, bare metal, run in the public cloud, private cloud, edge. There are all the different flavors there, right? So this is basically setting up my connection. So I run that. And then we're going to inspect the data set. Basically, I will show here by loading it into a pandas data frame that we actually have some information regarding, right? So this is basically the CrateDB data set that we basically use here. So this is Twitter support for Microsoft. We put that into a CSV file. We basically use that to actually fetch the data out of that. And you can see here, basically we were showing the first 5 rows. So we have the tweet ID, we have the author ID, we have the response ID. So that's basically what we have from a data perspective. So then we can say, okay, I want to display the basic information again, right? So we have a column, we have a data type. So this is more about, okay, what kind of data do we have actually within that CSV and how does that look like? And how do we need to, further down the lines, start to import things within CrateDB? What we're going to use here is OpenAI. So what I already did is enabled my OpenAI key, right? So if you run that again, you can see that it's not prompting you, but if you run this for yourself, you will be prompted for your OpenAI key. So that means you need to have the OpenAI key. But of course, if you don't want to use OpenAI, and you want to use another LLM, we also have an example further down the line here. You can, of course, use that as well. So then is the important part, right? So we use the CSV loader to load the support tickets from Twitter, right? Which we had in that CSV. And we're basically gonna initialize the vector search and store that within CrateDB and store those embeddings within CrateDB. So let me do that. So we're loading here, right? So we're using the CSV loader. We, of course, set the delimiter and that kind of stuff. So we have the data, and then we're going to store the data within CrateDB. So this is actually calling OpenAI to generate the embeddings. and to store those embeddings. So what we can do here is actually go to the CrateDB admin UI, right? So CrateDB, this is on our fully managed cloud, right? So this is, if you want to start using CrateDB, this is a great way of doing that. So you just go to console.crate.com, and basically you can deploy your CR3 cluster. That's a free cluster, free tier cluster. Of course, if you want to go for the full Monty and want to do some testing with, I don't know, that availability we have from the out of the box, of course, you can use your credit card and basically create a 3-node cluster, for example, and take it from there. But I would definitely advise you just to go there and create your simple free cluster to do some testing, initial testing. So if we go here, we look at the tables, we have a collection and we have an embedding. The collection was basically what we said earlier. We defined the collection name. So if we query the table, you get the name of this particular collection is called customer data. And we have a UUID, which may be further down the line if you want to do some operational reporting on what you have from an embeddings perspective, you can start doing that. So, but if you look at the embeddings table, we actually have 142 records into that table, and we have a couple of columns defined here. So let's query and let's have a look. So we have the collection ID, right? This is the collection ID that matches the other table with the collections, and you can see we have the embeddings here. So, well, as expected, that's a pretty high dimensional embedding. So for us humans, that not really, doesn't really make sense, right? It's difficult to comprehend more than 3 dimensions for us as humans. But this is, a very, very high dimensional embedding. And you can see some information here regarding the tweet, right? The order, the inbound, the created time. We also have some metadata there, right? Which is the support file, the customer ID, and the UUID. So as you can see here, it's not only storing the embeddings, but you can also store metadata of that particular tweet where you generated the embedding from, right? So I just wanted to show you that we actually store stuff within CrateDB after we ran this pipeline. So that was after this particular piece. And now we can, basically, this is our chatbot, right? So we have the question defined here. So how to update shipping address on an existing order in a Microsoft store. And of course, I would advise you to have a play with this, right? Change the question, do some different iterations and see what the LLM comes back with in regards. So you can run that. So that's the question. And then this is the important part where CrateDB again steps in, right? Here we do the similarity search within CrateDB. And what CrateDB can do with the K&M match function is basically looking at a vector, right? So we have the embedding stored. And with this question, what will happen is another embedding will be calculated for the question. And using that embedding that was calculated for the question, we go back to the database and say, hey, we have this embedding. Can you give us the closest or the most similar responses within that table? And that's basically what we are doing here. And that's an important part of finding that actual match, right? So if we basically, this is the prompt we give back again. So we went to the database, got the similarity. We now say, okay, we want to prompt it, right? So basically we're doing here, we have a system prompt. So basically giving the LLM some context, who we are, right? So we are a customer support expert and we are getting questions asked about Microsoft products and services. And basically also, this is important, right? To prevent hallucinations, you just need to say here, okay, if you can't find the relevant information for the context, say, I don't know, right? If you played with OpenAI, you know that OpenAI will always come back with a smart answer to your question, right? It will never say, I don't know. It will always come up with an answer. So this is important to set the scene for the LLM. And of course, we are actually providing the context that we are using to generate, right? So we're using that vector and the information we got from that tweet. And then we basically put it all together here, right? And then we have the answer. So if you look here, so this is basically the chat completion. And then basically you get the answer. Say, okay, to update the shipping address on an existing Microsoft order, you can order Microsoft support for assistance, right? So you can see that this is actually working quite nicely. But like I said, you can, of course, you can go back and say, I want to change the question, right? So instead of saying, I want to update my shipping address and how do I do that, you could say, okay, I have a bunch of FIFA points, and how can we do that? So if you rerun this, basically it does again find the similarity search, and then basically we're going to augment that prompt, and we're going to fetch the prompt, and we're going to complete the chat here, basically again coming back with a nice answer using the LLM, and then we're going to rerun, and basically you get a different answer, and so you can reach out to @Microsoft Help for assistance for making purchases on Xbox or FIFA points. So that's what I wanted to show you today. So very simple, very basic, but the good thing is you can all find that on GitHub, right? So github.com/crate/CrateDB/examples, -examples, and there you find a whole bunch of stuff. We will also post it here in the comments, so you can actually find it. So let me stop sharing. Well, I hope you found that quite amusing and interesting.